we are Group 4, and today we are presenting the design of a record player for manufacturing and assembly. In my group is Marco, Caitlin, Colin, Raymond, and myself. A record player is a mechanical device that plays audio from a vinyl record. It works by capturing unique grooves that produce vibrations that occur at individual frequencies. Its primary components consist of a vinyl record, stylus, turntable, and a cover. The annual estimated demand is approximately 50,000 units per year, and for reference, there were 82,000 record players that were sold in the U.S. in 2021. Primary customers generally represent the mass market, who may be casual music listeners, hobbyists, or aesthetic buyers, whereas secondary customers are more involved and in tune with the product, who may be serious music listeners, audiophiles, vinyl enthusiasts, or old-timers. This fast diagram shows the main function as play audio. The two subsets of that function is to produce sound and to amplify that sound. And to produce sound, you would rotate the record, which is driven by the motor, and to convert the vibrations into sound, which is done by following the grooves. To amplify sound, you will need to increase the phono signal. Some of the other functions include assuring dependability, which can be done by preventing scuffing, assuring convenience, enhancing the product. Some of the examples include pausing sound and controlling the volume and pleasing senses.
Okay, now moving to the assembly sequence analysis. First of all, we'll have a rubber foot. This will be followed by a subassembly comprised by the base, the motor, and the motor cover, the start-stop buttons, a central pin, a tone arm connector, the main gear, the tone arm itself, an aluminum platter, and a mat that will go on top of the speller, and to finalize everything, a dust cover that will cover up the whole base. For the second assembly, we will then start with the base, moving to the start-stop buttons, the central pin, then add the tone arm connector, the main gear, the tone arm itself, an aluminum platter, the mat, the dust cover, and then finalize it with a subassembly of the motor and the motor cover, and finally the rubber feet. Now, when comparing both of the assembly sequences side by side, we can see that sequence 1 comes on top due to having better scores on the ease of transferring and handling parts, the ease of fastening and joining, and the ease of testing the subassemblies. So, moving on, here's our function component mapping matrix. As you can see, most of the components are related either to the following the groove function or to preventing scuffing. And the majority of the components are related to more than two functions, with some more specific components being responsible to fulfilling only one of the functions.
Here's our record player bill of materials. Our 13-part BOM contains acrylic thermoformed parts, plastic and rubber injection molded parts, and aluminum parts which were machined, sheet metal formed, and die cast. We also used purchased electronics and fasteners. Our material, assembly, and tooling costs for each part were added up to get our total assembly cost of $52.95. This is on the low end of retail record player prices ranging from $50 to $350, making it about 26% of the retail price of a mid-range record player. Here's our quad chart. We analyze each component's functional importance as well as manufacturing costs to determine which components require redesign. Our cutoff for a low-cost part is any part with a total unit cost of less than $2.
Now we will be discussing the product family design. The functional differentiation table was created in regards to our fast diagram and the two customer groups that we established earlier. The two functions that were different in the customer groups were prevent scuffing and please senses. This is because the second customer group is much more focused on quality and lifetime span of the product, while the first customer group is much more focused on convenience. The modules that particularly pertain to these two functions are the tone arm and the aluminum platter, as those will be the things that we are looking at to improve on.
Next is the variants and interfaces. There are two modules that differentiate between the customer groups, the tone arms and the aluminum platters, both of which affect the sound quality and preservation of the vinyls. On the left, we have the primary customer group model, which is simple, easy to use, and the platter is solid. On the right, we have the secondary group model, which is a little bit more complex, more modular, and it has static reducing qualities, such as a hollow plate. It's grooved to allow for a slip mat, holes in the center of the plate to easily pick it up to disassemble, and a tone arm with a curved design rather than a straight design as in the primary model, which actually reduces static due to the angle of the needle. The interfaces between the tone arm and the vinyl platter are very simple. The tone arm just affixes to the tone arm connector, which is simply just sliding the tone arm to the connector. Same with a vinyl planer, it just slides through the central pin, which is in the center of vinyl, which is also where the slip mat and the vinyl itself is centered. On this slide, we have the product family assembly diagrams for the original and modified assembly sequences. On the first one, we have the assembly branching when the tone arm is assembled for the two different modules of tone arms and platters. And in this modified, we have it so that the dust cover is assembled previously to reduce the amount of variance at a later time in the assembly process. This concludes our presentation. Thank you for listening.